All right, so we are still on past question review, applied mechanics 2023 examination at the River State University, Port Harcourt, Nigeria. All right, but let's consider this other question. This is question 3. We've done question 1, question 2, and this is question 3. And question 3 happens to also be on three-dimensional force analysis. So let's consider the question. Question says, in picking up a load from position B, figure 3, a cable tension of magnitude 24 kilonewton was developed. Calculate the moment which T provides about the base O of the construction crane and its direction. So we have to find the moment of force generated or caused by this tension in this cable about the origin point O. Now, I've always said, whenever a problem is given to you in applied mechanics, always you outline your free body diagram. In this case now, there is a need to do your free body diagram because you're not going to be solving with this crane. So in attempting to draw a free body diagram, you can completely convert this whole crane to just be a single line. So you have something like this. Okay, this is your FBD, free body diagram. Free body diagram is simply a diagram of forces which shows all the hidden force on a system. Okay, you also have something like this. All right, and you have something like this. Okay, you have this height. Okay, and this is from point A. You have something like this. So you might want to do this if you wish. Not really important. All right, so you have this at point B. Okay, not forgetting distance here. You have something like this. Okay, and you have, yeah, you have something like this. Okay, so from here you're giving this distance to be equal to 6 meters, as can be seen here. So this is 6 meters. Similarly, you have from here to this point. Okay, you have from here to this point was given to you also as 6 meters, as can be seen here. So you have 6 meters. All right, not forgetting this is my y direction from the question. This is my y direction. This is my x direction. So the x direction points, you can actually wipe this. This is the x direction. Okay, so this is my x direction. And this is my z direction. So you have this to be your z direction. You have the tension in the cable T, and the value was given in the question as 24 kilonewtons. This is your origin O. That's your origin O. Okay, you have point A. Here is point A. You have here to be point B. Okay, distance from Z, let's put this here. Distance from Z to point A was given as 18 meters in the question. This distance was given as 18 meters, and this height was given as 30 meters, and this height was given as 30 meters. So you have this height 30 meters. All right, so I think this is your free body diagram. You're good to go. This is your free body diagram now, showing all the hidden tensions or forces and of course their dimensions on the diagram. This is your free body diagram. Now the question says we should find the magnitude and direction of the moment caused by this force. So you know that moment, first of all, is force times distance, and since this force is in space, then we have to find the position vector of the tension force in that cable first. Then we can use that idea to find the moment. So we did this in the second video, so you can as well watch the second video for proper understanding. Now the first thing to do is to find the position vector of the tension in the cable. In this case now, this is cable AB. This is cable A to B. So this tension is actually tension AB. Okay, this tension is actually tension A B, because this cable is between A, is tied at A and is pulling an object at point B from what the question is saying. So we start by looking for the position vector of A, B, that is simply RAB, okay? And I said to find the position vector, you simply move from where the fixed point, which is called the reference point, the point where the cable is tied to locate the other point. So you move, I said the point where the cable is tied is always called the reference point. So you move from the reference point to locate the other point. Cable is tied at point A, which means point A is my reference point. Hence, you move from point A to locate where? Point B. Now, if I want to locate point B, notice that I have to move downward from point A. Remember, I said in the previous video, in your Cartesian coordinate system, especially in 3 dimension, let's say this is our Y, and this is our X, and this is our Z. Then if I'm moving from the origin upward, if I'm moving vertically upwards, I'm going in the positive J direction. But if I move from the origin and move vertically downwards, then I'm moving in negative J direction. If I move from the origin and I move to the right in the positive X direction, this is simply plus I direction. But if I am going against that direction, then it becomes minus I. Hence, if I move in the direction of Z, this is now positive K. But if I am moving against direction of Z, it becomes minus K. So you have to keep these movements in your mind. Now, I want to locate point B from point A. I have to move from the reference point, which is point A. Notice that I am moving where? Downwards. And this direction was given in the equation to be the direction of Z. So Z is always the K direction, X is always the I direction, Y is always the J direction. Now, this means that moving upwards is supposed to give me positive K, and now I am moving where? Downwards. So I am going against the original direction of Z, and distance covered is what? 30 meters to get to this point. That means it becomes minus 30K. Minus because I am moving downwards. It doesn't end there. I need to locate point B, which means I have to first of all move from here to this point. This is the direction of X. This is the direction of positive X, and I am moving in this same direction, which means I am going in the positive direction of X. And the total distance covered moving in that direction is what? 6 meters as indicated in the question. I'm not forgetting X is always the I direction, and since I'm moving in the positive direction of X, then it becomes positive I. And I'm covering the total distance of what? 6 meters. Hence, I have this to be plus 6I direction. But it doesn't end. I need to locate point B, which means I have to move from here to this point, covering this distance. Now, what is from here to this point? If I am moving from here to this point, this is the direction of Y. Remember, this is the positive direction of Y, which is the J direction. Now, I am moving backwards against Y. Moving from here to this point is moving backwards against Y to locate point B. So, since I'm going backwards against Y, it becomes negative J, because Y is always the J direction. So, this becomes minus 6J. Now, minus 6 because total distance I move from here to this point is simply given here as what? 6 meters. So, it's negative again because it's going against the J direction. So, this is the first thing to do. Find the position vector. Next thing to do is to find the magnitude of the position vector. So, magnitude of position vector. Alright, and RAB magnitude simply means the square root of the sum of the squares of the individual positions. So I have minus 30 all squared, the positions obtained from the position vector, okay, plus next is 6. I have 6 all squared plus next is minus 6 all squared. So magnitude of position vector in cable AB is now equal to square root of minus 30 squared. When you square a negative value, you have a positive result. So minus 30 squared will simply give us 900 plus 6 squared will also give us 36 plus minus 6 squared also will give us plus 36. The square of a negative value becomes positive. Okay, so RAB is now equal to the square root of, let's add all of them together, 900 plus 36 gives us 972. So we need to now find the square root of 972, That gives us the magnitude of that position vector. So let's find the square root of 972. So the square root of 972 RAB magnitude simply gives us 31.2, approximately 31.2 meters. So this becomes the magnitude of the position vector. Now, after obtaining the magnitude of the position vector, the next thing to find is the unit vector. So we simply find the unit vector. All right. And how do you find unit vector? Lambda AC, which stands for unit vector, is simply position vector in cable AC all over the magnitude of the position vector in cable AC. It's as simple as this. So this is equal to, okay, let's do that over here. I think I can wipe the equation now. So the unit vector in cable AC is now equal to position vector in cable AC. We obtain the value as minus 30k plus 6i minus 6j. So we have minus 30k plus 6i minus 6j all over the magnitude of the position vector, and that magnitude gave us here as 31.2, all right, meters. So this is now divided by 31.2, and in the previous video I explained that this can also mean minus 30k all over 31.2 plus 6i all over 31.2 minus 6j all over 31.2. We simply have this. Okay, so lambda AC is now equal to, let's find that individual divisions. So minus 30 divides 31.2. That gives us minus 0.96k plus 6 divides 31.2. That gives us 0.19 I minus, of course, 6 divided 31.2 also 0.19 J. Okay. All right. So having found this now, the next thing to find is position vector of the cable or the tension, position vector of the tension in the cable. And I explained this in the previous video. The position vector of tension in cable AC is simply the magnitude of the tension in cable AC multiplied by the unit vector of tension in cable AC. And this is equal to, remember in the question it says the magnitude of the tension in cable AC is 24 kilonewtons, also stated here. So that means you have 24 by 10 to the power of 3, because it says 24 kilonewtons. So the magnitude of that tension in cable AC is 24 times 10 to the power of 3, or simply 24,000, multiplied by the unit vectors, and these are the value of the unit vectors, minus 0.96k plus 0.19i minus 0.19j. So the position vector of tension in cable AC is now equal to, let's now expand, 24,000 multiplies minus 0.96. That gives us 23040 minus 23040k plus 24,000 multiplies 0.19. That gives us 4560i, okay, minus 17. 24,000 multiplies minus 0.19, also 4560j. All right, so this becomes the position vector of the tension in cable AB. All right, but the question says we should find the moment of this tension about point O. So it's very simple. We know that moment is simply force times distance, but in this case, this is a three-dimensional moment. So moment about point O, that's what the question is asking us. This is now equal to the position vector of the cable tied at point A with respect to point O. Distance between this cable at point A with respect to point O, that simply becomes ROA. This is now the position between cable A and point O, this position where you're taking moment of this cable about. Now, times the position vector of the tension force in cable AB. That tension force in cable AB. So we simply multiply the position vector of the tension force with respect to the position or the distance between the cable and the point of moment, which is point O. So all we need to do now is simply what? Find ROA. What is now the position vector between point O and point A, which means position vector of the cable and the point of moment. It's a very simple concept. Remember, since the cable is started at point A, you move from point A to locate where the point of moment or the origin where you're taking moment about. So to move from point A down to this place means I am going backwards. Remember this direction is the y direction. So forgive me, this diagram is not properly drawn. Okay, okay, it should tilt a little bit, should be inclined a little bit, but this is the y direction, this is the y direction, not forgetting, this is the y direction. Now I am moving backwards, which means I am going against the direction of the j axis, and since I'm going against that direction, it becomes negative. Distance covered in this case is 18 meters as indicated here, so we have minus 18j. It becomes minus 18j. Then again, I'll move from here purely vertical to locate point O. I have to move from here purely vertical to locate point O, and this distance is what? The z direction. But now I am moving where? Downwards against the positive k direction. Since I'm moving downwards, then it becomes where? Negative. And again, total distance covered is this height, not forgetting. So it's just total distance covered is this height. So it's just like saying you want to still move from here, you can still move from here to locate where? Point O. If you move from here, which is point A, you've covered this distance acting downward, which is minus 30 in the k direction. So you've covered this distance vertically downwards, covering, since you're going against z now, it becomes minus because you're moving downwards. Then you move from here to this point, still covering what? This same distance. So it's virtually the same thing. Either moving from here, or you can still move from here to this point. It's still the same thing. So we have this to be the position minus 18j minus 30k. Now, if this is the position, all you need to do is multiply this to this, the tension, and you're good to go. Now, but if you go ahead to just do a simple expansion, you might actually be delayed or it might take you time. So you simply employ the idea of matrix, okay, to solve this problem. So you can simply use matrix to solve the problem. Let's do that here. So we're going to be using matrix. Okay, moment about point O is now equal to, let's use matrix to solve. This is our I, J, and this is our K. Not forgetting, always the first is the positive, J is negative, and this is positive. That's the direction of the matrix. Okay. So we start imputing what? Let's start with we can start with the tension, or you can start with the position vector. Let's start with the position vector. I have terms in only J and K. There is no term in I, hence I here is 0. I'm starting with the position now. Then J is minus 18. This is J coulomb, so put it down minus 18. For the K coulomb, we have minus 30. You put it down minus 30. Whereas for the tension force, in the I direction, we have 4, 5, 6, 0. So you put it down 4, 5, 6, 0. Okay. For the J coulomb, you have minus 4, 5, 6, 0, which is here. Put it down minus 4, 5, 6, 0. And finally, for the K, you have minus 23040 minus 23040. So this is as simple as this. Now, using matrix makes it easier. It's still the same thing as saying moment about O is equal to minus 18j minus 30k, okay, multiplying through by what? The values of this tension. It's still the same thing. Just that this will take you time trying to expand with each of these terms. Might take you time. So easily go with what? Matrix. It makes it easier for you. All right. So the moment about O now is equal to, remember, when evaluating with matrix, we want to start with the I direction. Remember, this is plus. So always you start with the plus I direction. Then you form your determinant matrix. Now, since I'm considering the I direction, it means I'm going to be blocking the column and this row and this column. I'm going to be blocking it, this row and this column. So which means I can only see what? These other two terms here from here to this point. I am crossing this row and this column I can only see these two terms. Now, what is the idea of matrix? Use the measure times measure, okay, the measure arm minus the minor arm. So this multiplies this. These are called the measure arm. I have minus 18, okay, minus 18 multiplying by what? Every time here, minus 23040. Okay, major arm minus the minor arm. Minor arm now becomes minus 30 times this. So I have minus 30 times minus 4560. I have this. So that becomes the first matrix for the first case. Okay, determinant matrix for the first case. All right. The next is J. Now, the J column has negative, so minus J. You form your determinant bar. Okay. Now, we are blocking. We are going to block the column of J or the J column. We are going to be blocking this column. So, if I block this column and this row, which means I'm not going to be seeing this again. This column and this row has been blocked. I am only left now with 0 and 4560 minus 30 and 23040. So I'm blocking the J column now and the row as well. So I only have 1, 2, 3, 4 to be seen. Again, measure arm. So it becomes 0 times this. I have 0 multiplied by minus 23040. Measure arm minus the minor arm. Minor arm becomes minus 30 multiplied by 4560. So I have again minus 30 times 45 times minus, okay, times 4560. Okay, I have this. So you form your determinant bar. That is it for the J. Finally, for K, K is positive. Remember, plus minus K is positive. So you have plus K. You form your determinant bar. Once again, you are now blocking this row and this column and this row. So you're only left with what? These two terms, 0 minus 18, 4560 and minus 4560. Once again, measure 0 times these terms. You have 0 multiplied by minus 4560 minus the minor arm, okay, which is now minus 18 multiplies 4560. So I have minus 18 times 4560. So you simply have something like this. All right, so the moment about O is now equal to, let's evaluate now. I have plus I into, so we simply find minus 18 multiplies minus 23040. Minus times minus is plus, so 18 times 23040, that gives us 414720. Okay, same thing here. Minus, now minus 30 times minus 4560, minus minus becomes plus. So I have 30 times 4560. That gives me 136,800. Okay. Next is for J, so minus J. Okay, so you have 0 times everything here becomes 0 minus, okay, minus times, okay, minus times minus here becomes plus. So I have 30 times 4560, which is 136,800, 136,800. I have this, and finally for K, plus K into 0 times this becomes 0 again, minus times minus here is plus. So I have 18 times 4560. That gives me 82080. So we have this. Okay. All right. So having obtained that value, moment about O is now equal to, so let's simply evaluate everything at once. It becomes now 414720 minus 136,800. That gives us 277920. So we have 277920. Remember, this is in the I direction. Not forgetting, this is multiplying by I. Next is minus J. So 0 plus 136,800 remains 136,800 times J. So you have minus 136, okay, minus 136,800 J. And finally for K, you also have 0 plus 82080. Okay, so plus 82080 Okay, all right. So the moment is simply equal to 277920I minus 136800J plus 82080K. All right, so this becomes the moment of force about point O. That's how you find your moment in three dimensions. Simply obtain the position vector between the cable, which is at point A, and the position you're looking for, or the point you want to take moment about, which is point O. So you can either move downward, like I said, from here to locate point O, or you can still move from here to locate point O. You still have the same position. Now, instead of going through the route of expanding, simply make use of matrix. It makes it very easier for you. That's the first question. The second question says we should find the direction of this moment. Now, to find direction of moment, it means you have to find the what? Magnitude of the moment. What we've solved so far is the position vector of moment, as can be seen. You have the unit vectors I, J, and K. Now, you need to find the magnitude of this moment. To find magnitude is very simple. Magnitude of moment about O simply is equal to the square root. Now you sum all, you take the squares of the individual term and then sum them up. It becomes 277920 all squared plus minus 136800 all squared plus, okay, 82080 all squared. Okay, so just like we did in the previous video, these values are too large, so I can't punch them individually, but in an exam condition, you're expected to find out the value of 277920 squared. Put it down, and of course the other values and their squares, put them down, then you sum them up. But I'm going to be punching all together because the values are too large. Okay. All right, so this gives me 9.5953 by 10 to the power of 10. That's to tell you how large the value is. But with the thing, we're taking square root. Hence, you find the square root of the value. That gives you the magnitude of the moment. So square root simply becomes, when you take the square root of that value, you're going to have 309,762.18 Newton meter. So this is the magnitude of the moment. This becomes the magnitude of the moment. Now we have to find the directions. So we'll simply use the same idea of directional cosines, which I did in question 2 for forces. We are still going to employ the same idea of directional cosines in this case. Now to find the directions, all you need to do is compare moment of force in three dimensions is always moment in the xi plus moment in the yj plus moment in the zk. So if you compare this with this result, okay, the result of moment about point O, comparing the two, you're going to have that mx is equal to, since this is mxi, and you have this to be in the I direction, you have 277,920 in the I direction. So it means mx is 277,920 because both of them are in the I direction. Similarly, my is equal to, comparing the terms in j, we'll have minus 136800j. So compare that in with this, you have that my is minus 136800. And finally, mz, comparing that of z in the k direction, you have 82080. It becomes 82080. Therefore, to find theta x, direction in the x-axis, just as explained in the second video, this becomes cos inverse of moment in the x direction all over the magnitude of the moment about point O. It's as simple as this. Therefore, theta x is equal to cos inverse. What is now the moment in the x direction? 277,920. You have 277,920 all over magnitude of moment about point O. We have the value here 309762. 309762.18. All right, so theta x is equal to the cos inverse of, let's obtain this division, 277,920 divides 30,9762.18. We have 0.8972. Alright, so in order to find theta x, of course, we take the cos inverse of that value. So cos inverse, that value gives us 26 degrees approximately. So the directional cosine in the x-axis is 26 degrees. That's 26 degrees. Similarly, to find that of y and that of z, we still maintain the same relationship, but now we are going to be effecting their values in the respective positions. That is talking about y and z. So theta y becomes what? Cos inverse of moment in the y-axis all over the magnitude of the moment about point O. So this is equal to the cos inverse of moment in the y-axis. We obtain that to be what? Minus 136,800. So you have minus 136,800 all over magnitude of that moment about point O is 309762. 309762.18. Okay, so let's obtain this value. Theta y is equal to, let's obtain that division, minus 136,800 divided by 309762.18. That gives us cos inverse of 0.4416. 0.4416. Therefore, theta y is equal to, now you find the cos inverse of that result. Cos inverse of answer gives us approximately 115 degrees. Approximately 115 degrees. And finally, theta z is equal to cos inverse of moment about z all over the magnitude of moment about point O, and this is equal to the cos inverse of moment about z. Moment about z simply gave us 82080, so we have 82080 all over magnitude of moment remains 309762.18. So theta z is equal to the cos inverse. Let's obtain that division. 82080 divides 309762.18. That gives us 0.2650. 0.2650 approximately. Hence, you find the cos inverse of that result. This implies theta z is equal to, let's find the cos inverse of that result. That gives us 75 degrees approximately. That gives us 75 degrees approximately. So the directions of the moments are theta x 26 degrees, theta y 115 degrees, and theta z 75 degrees. Alright guys, so that's it on question 3. In the next video, I will solve question 4 for you guys. Thanks guys, and I will see you in that video. Cheers.